This question is based on chemistry, chemical, kinetics chapter. So here in this question, for the decomposition of azoisopropane to hexane and nitrogen at 543 Kelvin, the following information is given. We have to find the rate constant. So these all pressure values are actually the total pressure. And we have to find the rate constant based on given information. So before we start the question, I just give you the idea how we will solve this problem. So first, we will find the K value based on the time of 360 seconds. So this suppose if it is a rate constant K1. Similarly, we find the rate constant of K2. After finding K1 and K2, we take the average of it, which is equal to K1 plus K2 by 2. And here I need to mention that this azoisopropane reaction is actually a first order reaction. So when we are using this first order reaction, K value is equal to 2.303 divided by T log P naught by P. So in the question, we don't know the value of P naught and P. So first we find the P naught and P value, and based on that we can find the value of K1 and K2 separately, and after that we take the average of it, so we can find the value of K. So let's start the question. Here, azoisopropane, its formula is C6H14N2. So when we do a chemical reaction, this is our chemical reaction. So when the reaction just started, means it's the initial phase of the reaction, that time the time is 0 second and the pressure is P naught. So this is the total pressure, and during that time product had no pressure because reaction just started. So in the question, total pressure when the time is equal to 0 is 35 mm. So we can use this relation and substitute it here. P total is equal to 35 mm. Now what is the total value of the first reaction? This one. Total pressure is equal to the sum of the pressure of all the three. So you see that it's equal to P naught plus 0 plus 0. It's equal to P naught. So from here we can say that total pressure in this case is 35, and this is the value of P naught. So we got the value of P naught. Now similarly we have to find the another relation, which is the value of P. Here this is the value of P we have to find. P naught we got, we have to find the value of P. So for this we are going to use the second relation. This relation we are going to use. So based on this relation, when the time is 360, when the T is equal to 360 second, that time total pressure is equal to 54 mm. Now when the reaction is completed, that time there will be certain loss of the pressure of the reactant. So the new pressure of the reactant is nothing but P naught minus P. This is P is with respect to the time 300 second. This could be vary when the time will change, but this is only for 360 second. Suppose if I write next one, T is equal to 720 seconds, that time the pressure will be P dash. It will not be the same. So now the product is P and P, and here the product is P dash and P dash. So the total pressure for the second relation is equal to the 54 mm, and when we add all of it, this total pressure is equal to P naught minus P plus P plus P. It's equal to P naught plus P, and P naught plus P is equal to total pressure. So if we further solve it, P naught already we got, it's equal to 35 mm. So 35 plus P is equal to 54. P is equal to 19 mm. So we got this value. Okay. Now we substitute it here. This is the pressure when the time is 360 seconds. So it's equal to 35 minus 19. So 16 mm. Now what we do? First we find the value of K1. K1 is equal to 2.303 divided by T1 log P naught minus the concentration of this part. So this is equal to K1 2.303, T1 is 360 into log P naught is 35 mm and this value is equal to 16 mm. So 35 divided by 16. So K1 is equal to 2.303 divided by 360 into log 2.187. Now K1 will be equal to 0.0021 second inverse. So we got the value of K1. Similarly, we have to find the value of K2 based on this relation. So here the total pressure when the time is 720 is equal to 63 mm. Now same repeated process we will do. Total pressure is equal to P naught minus P dash plus P dash plus P dash. This gets cancelled. P naught minus P dash is equal to total pressure 63. P naught is 35. So P dash is equal to 63 minus 35. It's equal to 28. So now we substitute the value here. 35 minus 28 is equal to 7 mm. So again we repeat the same process, but here P value is 7 mm, P naught will remain as 35 mm. So now K2 is equal to 2.303 divided by time is T2, it's 720 log P naught by P. So K2 is equal to 2.303 divided by 720 log 35 divided by 7. So these two gets cancelled 5 times. So K2 is equal to 2.303 divided by 720 into log 5. So this K2 will be equal to 0.00223 second inverse. Now we have the value of K1 and K2, but we have to find the average rate constant. So K is equal to K1 plus K2 divided by 2. 0.00217, that's the K1, and K2 is 0.00223, that's K2 divided by 2. So K is equal to 0.0044 by 2. K is equal to 0.0022 second inverse. So this is the answer of this question.